Hello, math students. Welcome back to our module on linear equations. This is lesson 17, and it is called the line joining two distinct points on the graph y equals mx plus b has slope m. The goal for today we will practice changing standard form into slope-intercept form. The question that I want you to think about during this lesson is, how do you determine the slope of a line if you only use an equation? So we have actually seen this before, and so it's kind of a review. The biggest thing that I want to do in this video is I just need you to really understand how you take standard form and convert it into slope-intercept form. And the reason why I want you to be able to do both is because when you get into algebra, you're going to have to understand the parts of standard form and the parts of slope-intercept form and how they are interchangeable, because there's going to be a lot of equations that you are working with quadratic formula that incorporates the parts of standard form, and if you forget what the parts are, then you're not going to know what you're looking at. So we have to be familiar with both types and both parts of both types. So we're going to give it a try. The first thing that we see is it says the standard form equation that they are giving us to start with is 35x minus 7y equals 49. And so if you remember the process for doing this, you take 35x minus 7y equals 49, and we're going to go ahead and identify each part. So the 35 is actually the a, and then you have the x value, right, minus 7 is going to represent the b, and then you have the y value, and then 49 represents the c. So if we go back to standard form, it's ax plus by equals c. Is it okay to have minus 7y? And the answer to that is yes, because subtraction is the same as adding the opposite. So if you want to change it to say plus by, then you would say plus a negative 7y, which is exactly the same thing. I'm going to go ahead and leave it like this because it helps me see what it is that I have to do to rearrange things. So this is truly in standard form. The a for this one is going to be 35. The b for this one is actually a negative 7, and the c for this one is 49. So those are all the parts of the standard form. You have the x value and the y value. That's if you were to plug in 0 for x, then you would solve for y. If you plug in 0 for y, then you would solve for x. And so that's what we're looking at in the standard form. So if you recall how to change this, so I'm going to draw a line under here, and we're actually going to convert it from standard form into slope-intercept form. The process of doing that is to take standard form and write it so that you're getting the y variable by itself. So I begin by looking, this is a positive 35x, so I'm going to subtract 35x from both sides. And so it looks like that. This becomes a 0 pair, and so 0 minus 7y, I still have 7y on the left-hand side of my equation. But now, because I'm looking for slope-intercept form, I'm going to write negative 35x, and this is a positive 49, so plus 49. And the reason why I want to do that is if you can recall when you're working in slope-intercept form, this value sitting right here is where you understand where your slope is. So I always put the negative 35x or whatever has the x attached to it first in the math sentence, and then I add or I subtract whatever the value of c is. So that's what that looks like. And then to finish it up, I have to get y by itself, so I'm going to divide everything by a negative 7. Take the negative with you always. So divide by negative 7, divide by negative 7, and now I'm left with y equals negative 35 divided by a negative 7 is actually a positive 5x. Then I have a positive 49 divided by a negative 7, that gives me a negative 7, okay? And so now I have changed this standard form into slope-intercept form. So the final answer is y equals 5x minus 7. So I went from it looking like this to converting into this, okay? These two are equivalent. They're exactly the same, okay? And so now what we're going to do that we have done that transformation from standard form to slope-intercept form, we're going to name the parts of the linear equation. The linear equation that we're talking about is this one right here that we just converted. Okay, so if you're looking for naming the parts, let's go ahead and write it down here. So we have y equals 5x minus 7, and we're going to name all of the parts. So this guy right here, the y value, this right here is your y value, because what it's telling you is what is the value of y. Well, the value of y in this problem is 5x minus 7. That's the value of y, so that's the y value. The slope in this problem is going to be this one right here. This is your slope, okay? And remember, another name for slope is m, and another name for m is slope or unit rate or rate of change. So all of these right here, so 5 is the slope, okay? The x value is this little guy right here, because it's asking you what number was multiplied by 5 to get us to y. So this right here is the x value, okay? And then the last one is called a constant. Now, here is where we have to do a transition in our thinking, because you all are used to the constant being what makes a statement proportional. We're moving away from that because you guys are getting closer and closer. Every day we get closer and closer to 8th grade, you're moving into algebra. And in algebra, what the constant means is something completely different. So this whole value right here is your constant. It is known as the b, okay? Now, why is it the b? Well, if you go back to our introduction of what slope-intercept form is, we learned that slope-intercept form is y equals mx plus b, okay? Now, the b, it's called a constant when you get into algebra. So you need to do a transition in your mind that this is the constant. And the constant's job when you're working in algebra, the constant's job, so the constants, you need to write this down, the constant's job in algebra, sorry, I spelled that wrong. The constant's job in algebra is to tell where the linear equation or line crosses the y-axis. And that is a very, very important thing to remember. So this b right here, its job, and it's very, very important, the constant's job, which the constant is the b, the constant's job in algebra is to tell where the line crosses the y-axis. And that is a very, very, very important thing to remember. And so if we're looking at this equation right here that we have, and we drew a rough sketch of a graph right here, immediately I can graph this very easily because I know where the line is going to cross the y-axis. This is the y-axis, boys and girls. So automatically I know that at the point 0, negative 7, so that means I have to go 1, 2, 3, 4, 5, 6, 7, I'm going to put a dot. And the reason I'm going to put a dot right there is because of that b. That b, which happens to be right here in this equation, is telling me that this is where my linear equation is crossing the y-axis. So then, once you have that point located, you can finish graphing the line without even having the graph. And here's how. Once you figure out where it crosses the y-axis, then your job is to apply the slope. Well, my slope says 5. So what that means is, if you're turning that into, remember, rise over run, and I get an answer of 5, how did I get that? Well, how I know I got it is that I rose 5 and I ran 1. That's how I get it, because 5 divided by 1 is 5. So if you have a slope of 5, that means you're going to rise 5, run 1. So what that means is I go up 5, and I'm changing the color because I want you to see this change. I'm going to go up 5, so 1, 2, 3, 4, 5, and I go over 1, 2, 3, 4, 5, and I go over 1. So that's my next point, okay? And if I was to do that again, same thing, still using my slope, because my slope says that I rise 5 and I run 1, then I'm going to go 1, 2, 3, 4, 5, and this time I'm going to go over 1 from where I am, right? So I go 1, 2, 3, 4, 5, and over 1. Here's my next point on my line. And you will just keep doing that until your line is drawn completely. And you've already learned from me multiple times that you only have to have 2 points to make a straight line. 2 points, that's all you have to find. So if we're given where the line crosses the y-axis, which you are given that when you identify the b, and then you have your slope, 1, 2, there are your points, and then remember the definition of a line is that it extends in both directions for infinity time, then all you have to do is take out, as I've showed you multiple times, your handy dandy, and because I'm not on a graph paper, it's not going to look perfect, but your handy dandy straight edge, and then you have your linear equation of this equation right here. Here is your line of this linear equation, okay? So you just proved that by taking standard form, turning it into slope-intercept form, you can very easily graph it just by knowing the parts, okay? So, in review, what I would say the most important parts of slope-intercept form, the most important parts are this guy, because this guy is to B, right? And this guy, let's do this color because it'll stand out, because it's the M. And once you can figure out what the M and the B are, if you know your M, if you can list your M and you can list your B, then very, very easily you can graph that on any coordinate plane, okay? And so that's why identifying the parts are so important. So, standard form, first job is to convert it into slope-intercept form. Then once you have slope-intercept form, you're going to find your M and find your B, and then you very easily can graph it just from those 2 points, okay? And remember, this is called a constant, and what the constant is it's also the B. The word is constant. The letter is the constant. For some reason, they call it a B. And the constant's job in algebra is to tell where the line crosses the y-axis. That's what you have to remember, okay? So going back to our goal, today we will practice changing standard form into slope-intercept form, which we just did. How do you determine the slope of a line if you only use an equation? Well, here's your equation. So take standard form, convert it into slope-intercept form, and by the time you're done, the slope is right there. It's very easy to identify. So do you see why I think it's really important to know how to transform from standard form to slope-intercept form? Because just by doing math, you found the slope. You don't have to add or subtract. You don't have to plot 2 points. You don't have to find the difference from the rise and find the difference from the run. All you have to do is convert from standard form to slope-intercept form, and then you've got your slope right there. Okay? So pretty fun lesson, especially if you like to do algebra stuff and then throwing in graphing when you're done. Okay, kiddos, that's all I have for you in this lesson. Talk to you soon. Bye.